we are going to start the new question of June-July 2011 paper solution of crystals. It is the question of crystal structure. Now let us start the derivation of this equation. D is equal to A upon under root h square plus k square plus l square. This is the question which is asked from crystal structure, and we are going to derive this equation. Here D is represented as interplanar distances, which is equal to A upon under root h square plus k square plus l square, where HKL represents a family of planes. To derive this interplanar distance, we are going to just get the equation. Let us start with the equation first of all. In this equation, here you can see the coordinates x, y and z, and this is a plane having A, B, C. This plane A, B, C is inside a crystal having the Miller indices H, K and L. To know the interplanar distance, D is equal to A upon under root h square k square plus l square. We are considering a line which is exactly perpendicular to the plane, or that line, perpendicular line, is passing through the plane. From the origin to the point N, actually this is the interplanar distance. If I consider OA, then OA is the intercept. Accordingly, OB is the intercept, and accordingly OC is the intercept. And if we consider this line which is passing through the plane, then this line making an angle of alpha dash with x-axis, it is also making an angle with y-axis, that is beta dash, and it is also making an angle y with z-axis, that is gamma dash. So the distance of this plane from the origin is up to ON. So we are considering ON is equal to D, and D is the interplanar distance. If we draw one more plane, then the distance from O to N is same as that of the another plane. So we will consider the distance OA, OB and OC, and found the Miller indices, and from that we will prove the equation or derive the equation. Let us move to that equation. Here OA is the intercept, which is equal to P into A. In the same manner, OB is also interplanar distance, which is equal to Q into A. And in the same manner, OC is equal to R into A. So here P, Q and R are the numerical values of the axis. P, Q and R are the numerical value of the axis. So in the same manner, here P, Q and R are the numerical values of the axis, and its reciprocal are the Miller indices. That is, P is equal to 1 upon H is the reciprocal, Q is equal to 1 upon K, and R is equal to 1 upon L are the reciprocal. In the same manner, if we substitute the values of P, then P is equal to 1 upon H. So OA is equal to A upon H. In the same manner, Q is equal to 1 upon K, that is OB is equal to A upon K, and in the same manner R is equal to 1 upon L, so it will be OC is equal to A upon L. So where A is the length of the cubic edge, so we can write that OA is to OB is to OC is equal to A upon H is to A upon K is to A upon L. So considering the equation or triangle NOA, the cos alpha is equal to D upon OA, and actually OA is equal to A upon H. In the same manner, cos beta dash is equal to D upon OB, which is equal to D upon A upon K. And in the same manner, cos gamma dash is equal to D upon OC, which is equal to D upon A upon L. So by substituting these all values in the cosine law, cos square alpha plus cos square beta dash plus cos square gamma dash is equal to 1, where cos square alpha dash is equal to D square H square upon A square plus D square K square upon A square. Here you can see it in the equation, D square K square upon A square plus D square L square upon A square, which is equal to 1. Here in this term, D square upon A square could be taken out common. So D square upon A square into H square plus K square plus L square is equal to 1. So we get an equation that D square is equal to A square upon H square plus K square plus L square. In the same manner, if we take out this square, it will become square root on the opposite side. So DHKL is equal to A upon under root H square plus K square plus L square. So this is the equation. D is equal to A upon under root H square plus K square plus L square. So in the above equation, this is the equation to obtain the interplanar distance. In this slide, here the length of the cubic edge is given. The diagram is of body centered cubic, where you can see that it is noted with the red line that A represents the cubic length, which is shown in a body centered cubic. It could be in also simple cubic also, and it could be also in face centered cubic. But cubic length could be different for different crystal systems. So in this manner, you can derive the equation for interplanar distance. Let us move towards the next question in our slide. Here in this question, question 3b represents the construction, working and application of LED. This question is asked for 5 marks. Let us move towards the slide. It is working on a principle of Electro Illuminance. Principle is LED is based on the phenomena of Electro Illuminance, which is the emission of light from a semiconductor material under the influence of an electric field. That means when we are applying an electric field to a semiconductor, an energy is created which is observed in the form of light in light emitting diode, that is LED. In the simple diode, it is in the form of heat. That means when we compare LED and simple diode, the energy is converted into light, whereas in normal diode the energy is converted into heat. That is, LED is based on the phenomena of electroilluminance, that is, when you apply or when LED is under the influence of electric field, it will emit light. Now let us go to construction. This is the symbol of LED. Here you can see that the arrow end is anode as well as the another end, bar end, is cathode. The arrow which is coming outside the diode is representing the emission of photon. That means when it is coming out, it represents the symbol of photon. That means this is the symbol of LED, that is light emitting diode. Now let us go to it. A cross section view of typical diffuse LED is shown in the figure. In our next slide, we will observe the cross section view of LED, which is made up of a PN junction semiconductor. An N-type epitaxial layer is grown upon a substrate and P region is produced by diffusion. Here, diffusion is a process to prepare a PN junction. Here, a N-type epitaxial layer is grown upon a substrate and P region is produced by diffusion. First of all, let us go towards the cross section of that diagram. This is the LED cross section. Here you can see that a P type is on the upper side and N type is on the lower side. When an electric field is applied between the P type and N type, that means in N type electrons are the majority charge carriers, whereas in P type holes are the majority charge carriers. When you apply electric field, then at the junction the recombination takes place, due to which the light in the form of photon is getting emitted. Here in the diagram you can see that there is charge carrier recombination, that near the junction the holes and electrons get recombined and it is converted into energy. It is called light, or it is in the form of photon. Let us move towards the next slide. The charge carrier recombination occur in P region, hence it is kept uppermost to allow light to escape. That means in it, P region is kept uppermost so that light can escape from it. A gold film is applied at the bottom of the to reflect the light as much as possible towards the surface of the devices. To provide a cathode connection, the metal anode are made to the outer edges of P layer. Working of an LED. LED are current driven devices. Actually, LEDs are current driven devices. LED work on a particular threshold voltage. That means when current are passing through the LED, then they are called current driven devices when a threshold voltage is achieved. And LED emits light at a particular threshold voltage. So each color of LED are having a particular threshold voltage. When PN junction of the LED is forward biased, free electron crosses the junction and fall into the holes. As these electrons falls from a higher energy level to lower energy level, they radiate energy. This means energy is gained by the electron when you apply electric field, and that electron is going to higher energy level. When it falls back from higher energy level to lower energy level, they radiates energy. My dear friends, this energy which is getting radiated is converted, or it is in the form of light in light emitting diode, whereas in normal this energy is in the form of heat. Let us move towards the next slide. In normal diode, this energy is radiated is in the form of heat. but LEDs have the unique ability while conducting current through them. These are the applications of LED. We concluded that principle, construction and working, and at last we will complete this question with the application. LED that emits visible radiation are useful in instrumentations, big size clocks, calculators, phone caller IDs, infrared LEDs. That means LEDs also emit infrared lights. CD players, remote controls of TV, burglar alarm system, etc. are some of the instruments where infrared LEDs are used. So these are some of the applications of LEDs. Let us move towards the next question. Calculate the interplanar distances for 3 to 1 plane in simple cubic lattice with interatomic spacing equal to 4.12 angstrom. Now, this is one of the numerical which is asked from a crystal structure. When we calculate this, we have to calculate the interplanar distances. In the previous question, we derived the equation of interplanar distances, and with the help of this, we will calculate the same sum and calculate the interplanar distances between the atoms for a particular plane having a particular Miller indices. So let us calculate that, and first of all, before calculating, we will read the question again. Calculate the interplanar distance for 3 to 1 plane in simple cubic lattice with interatomic spacing equal to 4.12 angstrom. Now here 3 to 1 is HKL, that means it is the Miller indice value for a plane in a simple cubic lattice, and interatomic spacing is 4.12 angstrom, which represents A. So we will calculate it here.